Okay, in this part of the video, we're going to go over how to use a multimeter. Multimeter is a very handy tool to have for all these circuit labs and so forth. What we have here is a power supply. This happens to be DC power supply. I'm going to turn it on. We have our multimeter, which we're going to kind of describe, and then we have a circuit board, and we're going to show a few ways, mostly how to get a capacitance, a resistance, current, and voltage with a multimeter. So the first thing we're going to talk about, this is our multimeter. It does multiple things. This little V with the sine wave above it is for AC voltage. Moving over to the right, we have a V with a solid line and a dotted line horizontally. That is voltage in DC. Here we have millivolts. We're not going to talk about that today. We've got ohms, where we can measure resistance with the ohm symbol. Over here we can check continuity. Rarely do we use it, but if you wanted to make sure that a fuse was good, we could touch both ends and it'll beep if there's a path through it. Here we have diode, and then note in yellow here we have a capacitance or a capacitor symbol, and note it's yellow, so if we're going to use that, we're going to push this button here, and now it's in farads or microfarads, and that will do capacitance. Down here we have amps in AC. Again, we have our AC symbol. It also measure frequency. We're rarely going to use frequency because we'll have a function generator that will give us that. And last but not least, we have amps or current DC. Again, it has the solid horizontal line and the dotted line. So we're going to turn this off, and we're going to make a quick circuit. Looking at the circuit board, we're going to look at really a few things, but really these are resistors. These three right here are resistors. These are capacitors. And let's just start out with, if we wanted to get a capacitance, what would we do? Well, we'd turn over to the capacitance here. We would hit the yellow button to get the capacitance. We would take and we would discharge our capacitor. Make sure there's no charge in it. And then one thing about a capacitor compared to a resistor is it's polarity dependent, meaning that we can only go through one way. The high voltage or high potential is here, and the low potential is here. These actually have little arrows on them showing the direction through here. You can't probably see it because of the numbers I put on here for doing some of our labs. But now everything on a multimeter except current is done in these two here, these two ports. We've got a common, and then this red one here, this for voltage, it would be the high potential. So we're going to plug into here because this will do our capacitance. And we're going to put this on the high side of the capacitor, and this on the lower side. And here it starts to fill in. This one happens to be, it takes just a minute to stabilize, but this is 2,223 microfarad, 2,222 microfarad. And that's how we use the meter for capacitance. Note that there's no current, nothing is hooked up to it. No power is hooked up to it. Now another common thing that we do with a multimeter is to measure resistances. Now we don't want anything hooked up while we're measuring resistances. Here again we'll have a common. We'll always have a common no matter what function we're in on the multimeter. And we're going to come in here, and then the resistor doesn't care which way you go through it, so we're just going to measure across here. And that one is a 200 nominal, I know that, but it's 207 ohms. And we can just go right across and measure ohms of all these resistors. And that's how we use the meter for resistance. Now we're going to show how to get a voltage across something. It could be various things, but here's our power supply. So here's our high potential. We'll come down here. Actually, let's go here. And then our low potential. So we're going through this resistor. We're going to turn the voltage up, let's say to 6 volts or 3 volts. Let's go to 3. All right, close enough to 3 volts. Now if we wanted to measure across that, we're going to put this on voltage DC. I'm going to put a wire into the common, put a wire into the V here, and we're going to measure the voltage. Now notice that this is going to be in series, or I'm sorry, in parallel across that resistor. And note here that that's 302, this is 301 or 3.016. This would round to a 2, so they are measuring the same thing. And that's how we'll measure voltage. One neat thing about voltage, if we want to know direction, what this means is that the high potential is at the red wire and the low potentials at the black wire. If we're to switch these, the neat thing about a multimeter is it'll just show us the direction, or direction is a good way to think about it. But now we have the high potential on the common and the low potential here. So that's because of the minus sign. This gives us a minus sign. That really comes in handy when we're looking at direction of current. Another common thing to do is to use it to measure voltage. The easiest way I could show this, demonstrate this, is we'll put it on voltage DC. We're going to have the red wire in here, black wire in common, and let's just measure directly to our power supply. So here, I measure, this is the output of our power supply, and that's how we measure it. Notice that it's in series, in parallel, not in series, it's in parallel is how we wire the voltmeter. This is 3.017. If we rounded the 7, that's a 2, and it matches our power supply. So that's how we'll measure voltages. Now the other common thing is to measure currents. I'm going to make a really simple series circuit with our 2 resistors. So we go into resistor 1, or 2 actually, this resistor. We're going to come out of that one into this resistor here, and then we'll take it back to the power supply. We might use black for that. So here we go. There we go. That's a live active circuit. We're coming in R2 into R3 and so forth. So if I want to measure current, we have to have the meter in series, just like these resistors are, with the meter. So if we wanted to break the circuit here, then we're going to break the circuit. And now that what we'll do is we'll simply go through the meter first. So we reroute through the meter in the amp one, out of the common, and back here. Oh, we have to be, I made a mistake, we have to be in amps DC. So there we are, we're fluctuating between 10 milliamps and 9 milliamps. And that's how we're going to do our currents. One other thing about currents. Now that means that the current, obviously it flows into the red, into this right here, and out of the black. That's the direction it's going, because we don't have a minus sign here. If we were to switch these around on our meter, it can give us a direction, because now we have a minus in front of the value. That means that we're actually coming into the common and out of this A, or the amps. So that tells us kind of the direction. So we know now that that current is going in here and out of there. Okay? And that's how we're going to use that particular function. And I believe that wraps up our introduction to using a multimeter.